All right. Now we come to the crux of this diversion into matrices, and this is the reason we do it, is because we can actually use matrices to show transformations of equations. And the way it works is fairly straightforward and rather simple. And the reason we do it is because a matrix can show multiple transformations in the one matrix, whereas with transformations we have to take it step by step. So matrices were really helpful in this regard. So I'll just insert a picture. You might remember this from our work with transformations. I think it's that one. There we go. So this is going to sit to the side there and we'll refer back to it as we go. So now we're going to have a look at a few things. We've got reflection in the x-axis, and that was where the y values changed. Reflection across the y-axis, that was there the x values changed. Dilation from the y, which was where the x values changed. Dilation from the x, which was where the y values changed. We haven't looked at reflection across this line here, so just ignore that for now. And translation, which was where they moved. So not multiplied like these ones up here, but physically moved, translated to the side. All right, and we'll look at that in a second. So just to give you a bit of the backstory, this is why it works. So you can set this up to be an image matrix. All right, and remember the image was whatever happened to the original points. So this is the way it works. Now, if you remember your multiplication of matrices, you have rows times columns, rows times columns. I'll change the color of that one there so we can look at the two effects. All right, so if we multiply this out, we're going to have a matrix that looks like this. It's going to be AX plus BY, and then it's going to be CX plus DY. All right, now if this top line here is equal to the image and this bottom line here is equal to the image of y, you can imagine that if we don't want a change to the x affecting the y, so this needs to be a 0, which means that the c value needs to be a 0. So we've got ourselves a 0 here. Now in the top line, we don't need a change in the y affecting the x value, so that there needs to be a 0, which means the b value needs to be a 0. All right, so now we're going to have a matrix that looks like this being multiplied to x, y. And what that will do is produce a result like this, where there's no y value in the top row, no x value in the bottom row, but there will be a change to either the x or the y variables, which we can read off. All right, now hopefully one of these things up here has happened. Either the y value has become negative, or the x value has become negative, or the x value has been multiplied by a dilation factor, or same for the y value, or the x and y values have swapped, or they've been translated. All right, so this is what the transformation matrix looks like at a basic level. All right, for this to happen, there needs to be zeros in this place here, these two columns, diagonals. All right, so keep that in mind. This is how it runs. All right, so I've just added in the actual transformation matrices that we'll use most of the time, and you need to put these into your notes. All right, and it tells us what we already knew. So the two diagonals from top right, bottom left are zeros. All right, apart from this one here, which we'll come to in a second. Don't worry about that. So reflection, we notice that the reflection across the x-axis, looking over here, reflection across the x-axis, the y value had to change, so the negative is in the bottom because that's where the y value is being affected. Reflection across the y-axis, the negative is in the top line because that's where the x value is being affected. Dilation from the y-axis, looking over here, that affected the x value, so it has to be in the top line. Dilation from the x-axis has to be in the bottom line because it affects the y value. All right, so these here make a little bit of sense so far. So let's have a look at an example. We'll jump straight into examples because I find that this works best with straight examples. All right, so the first one says we have a point 2, 3. All right, and we want to do the two different things. We want to reflect it across the x-axis. Reflect in x. All right, so first thing we're going to do is look up this reflection across the x-axis matrix, which is just here. So it has to be 2, 3, and you have to remember that x goes on top, y goes on the bottom. We're going to multiply that. Now, if you remember what we had underneath this table here, we had to have the point, or just actually got it written here, we have to have the point written second because of the way matrices multiply. So the first thing we're going to do is write down the transformation matrix that gets us a reflection across the y-axis, which is, reflection across the x-axis, which is this one here. All right, so 2, 3. Now, if I multiply these out, I get rows times columns, so it's going to give me 1 times 2, which is 2, plus 0, which is just 0. Remember that that 0 has to be there to make sure that the y value doesn't affect the x value. All right, then the other row times the same column, it's going to be 0 times 2, which is 0, plus, but this is a minus 1 now times 3, so it's minus 3. All right, and what you'll notice is that the new matrix, when we simplify it, is 2 minus 3. All right, so what's happened? The y value has become negative. So let's go back over here to the original table and have a look. Reflection in the x-axis. Look, the y value becomes negative, and that's exactly what's happened from 3 to negative 3. All right, so the next thing for the same question with the same 0.23 is to dilate it by a factor of k from the y-axis. All right, so if we look back up here, dilation from the y-axis affects the x variable. If we look over here in the matrix table, we have dilation from the y-axis. This is the table or the matrix we're going to use. So it's going to be k, 0, 0, 1 multiplied by the point, and it's going to produce us an answer of 2k and 3. Now, I've had a lot of practice with this, and I can see pretty quickly that 0 times 3 for the first line is going to be 0, and 0 times 2 for the second line is going to be 0. So there's no need for me to write down this here unless I'm not sure. All right, so for the start, I think you should write it down. But as you get more and more confident, you can see that the zeros are just going to disappear. All right, so let's looking back at the original table, we can see up here that dilation from the y-axis dilates by the factor of k, and it's on the x variable. If we look at our answer down here, we can see the k is multiplied to the x. That shouldn't be, yes it should. The x is 2, so 2 times whatever k is moves it further away. Looking back up the top, you can see that the y hasn't moved, and we can see the same thing happening here. Now, I can hear almost everybody in the background saying that this hasn't made your job any easier. We could have done this by sight very quickly and very easily using just this information here, and you're right, we could have. Where matrices tends to make things a lot easier is when you have combinations of transformations occurring at the same time, and we'll do an example like that in a few minutes. In the meantime, if you want to practice more on this particular skill here, you can go to question 4 in the set and work for that. But we're going to have another look at a combination of changes now. So I'll put push this to the side, but I might make, oops, no, ignore that. Let's just work underneath in this space here. So the first one we're going to have a look at is the example in the set, example 13. So it says that we have a point of 2 minus 3, and it is being reflected in the x, followed by a dilation of k from y. All right, now this is where order is vitally important. So we've got transformation 1 and transformation 2. All right, so your first step is to identify the matrices that you're going to use to show each transformation. So reflection in the x is this top matrix here. So it's going to be 1, 0, 0, minus 1. Then dilation factor from the y-axis is going to be this matrix here, and it's going to be k, 0, 0, 1. All right, now because these have to happen in a particular order, we have to multiply them in a particular order. Before I go any further, I'll just point out that this is the example we talked about earlier where this is where matrices really stands out, because we can combine these two effects into one matrix and then have to do only one multiplication over here instead of doing it twice. All right, so we're going to do what's called composing a new matrix made up of these two. All right, so the key here is that this is matrix A and this is matrix B, and to compose them or multiply them into one, we need to compose them in a certain way, and that way is B times A. So B has to go first, all right, and one reason that you could use to think about this is that when you multiply it by the point, all right, so BA times the point, you want the first transformation to be closest to the point. So B has to go out furthest away. All right, so let's look at this multiplication. Here we're going to go rows times columns. So it's going to be K plus 0. That's the first point there. Then it's going to be rows times columns there. So it's going to be 0, because K times 0 plus 0 times minus 1. Then it's going to be this row by this column. So it's going to be 0 there, because 0 times 1 plus 1 times 0. Then it's going to be this row times this column. It's going to be 0 plus minus 1, so it's going to be minus 1 like that. All right, so this is the combination of the two transformation matrices. Notice that it's got a K, it's got a minus 1, it's got all the important information. So now we're going to multiply it by the point that we needed to have transformed, which was 2 minus 3. And it's going to be rows by columns. So it's going to be 2K plus 0 times minus 3, which is 0. And then it's going to be 0 times 2 plus minus 1 times minus 3, which is just positive 3. So the transformation of the point leads us to a new point, which has been dilated by a factor of k and is no longer negative, which we should know is how we change the reflection in the x-axis. All right, so this is an example of where matrices can help, because we can combine multiple transformations into one matrix and then change the point all at once.